Okay, today we got graphing systems of linear inequalities. Um, this is going to be very similar to system of linear equations, except that we're going to just be doing inequalities. We got some shading and stuff like that there. So, okay, to do this, not too bad. You need to solve both of your equations and get them equal to y. So we have x minus y less than or equal to 2. So we're going to subtract over x. That's a negative y less than or equal to negative x plus 2. And then you have to divide everything by negative 1 right here, which is going to flip all of the signs. And what I mean by all is also the inequality sign. Whenever you divide by a negative, your inequality sign is going to change there. So you might even want to highlight something, maybe draw like a little arrow. Got to be careful. That'll affect the shading. Now, if you've already watched the video or already saw in class, you know how you do the shading as far as up and down. You can do that in dotted solid, that type of stuff. You need to be looking out for those there. So this one here, apparently it's a line starts at negative 2. Just like yesterday, it's got a slope of 1 or implied 1 right there. So you go up 1, right 1. And I'm going to get a couple of these points here. And then, like said earlier, should have a solid line. Yeah, it looks like it came out real good there. Okay, I guess I graphed it in the wrong color. My bad there. Here, actually, I can do this. Change, convert. No, what do I want? Style. There we go. Just so I have it matching up. Okay, the second equation we'll do in blue here. So it's 2y greater than or equal to 2. So we're going to subtract x, and that's 2y greater than or equal to negative x plus 2, and then divide everything by 2. So that'll be y greater than or equal to, that'll be like negative 1/2 x, and then plus 1. Okay, then that'll be starting at 1, and then a slope of negative 1/2. Now these, it doesn't matter as much if they actually intersect at a bulleted point. We're not actually concerned about where they exactly intersect. We care where the shadings intersect. And here's what I mean by that. So going back to the red equation right here, we had greater than. So that means we shade everything above the red line. So I'm going to shade that whole region, everything above the red. Okay. Now with the blue equation right here, we had also, I guess, greater than on that one. So we're going to shade everything here above the blue region. And the whole idea with this was systems of, I guess, inequalities is the overlapping region right here is where all of our actual solutions are for both equations. So anything in this region, oh, whoops, I didn't mean to do that, but anything in this overlapped region right here is where your solutions are. So I'm even going to, plot a point or something like right here. So we're going to say that that is a solution to both inequalities right there. Like something that's not in the shaded region right here is not a solution to both at the same time. Whoops. Both. And obviously, like something over here, definitely not a solution. So the solution to both inequalities at the same time. So basically, you're looking for an overlap in, I guess, the shaded regions. And that might be something good to write down there. Overlap in the shaded regions. Okay. So that's that. Let's look at this one here. Sometimes they'll give you these ones that are only dealing with like x and y. So if you think back to like algebra 1, if we have y is less than or equal to 3, we know that that was a horizontal line through the y-axis at 3 right there. And since it was equal to, it looks like we're going to have a solid line right there. And then, yeah, just make sure it goes to 3. Okay, as far as your x1 right here, so that's going to go through 2 on the x-axis right here. It's a vertical line, except they want it to be a dashed line. Okay, now let's get to shading here. So for the blue line, we have less than or equal to 3, so that's everything below the blue line right there. And then also you have less than 2. Now you don't have like up and down, I guess, for when you're dealing with equations dealing with the x. X is great, or actually it's greater than 2. But anyways, you don't have left and right, or you don't have up and down, so you have to do left and right. So all the x values that are like bigger, I guess, than 2 are going to be over here on this right side. So we're going to shade the right side right here. So everything in this region right here is a solution. So usually, like I tell students, to just like kind of make sure it's darkened a little bit more than everything, so we kind of know like what your solution is and what you're talking about. So that's that. Let's see what's going on with these last 2 examples here. Some of them we'll have to solve, like that one right there. So 4x plus 2y greater than or equal to 8. And then what are we doing here? I guess minus 4x. So that's 2y greater than or equal to negative 4x and plus 8. Then divide by 2. You don't flip the signs here because you're not dividing by a negative number. So it keeps as 2x, it keeps as greater than, I guess, and then plus 4. I guess I'll go ahead and graph that there. So that is one equation. Actually, the other one's ready to go, so that's kind of nice. All right, so start at 4. It's a slope of negative 2 over 1. So down to right 1. You can even go up and left. You need a few more points. We got an equal to line, so that should be a solid line. So I'll try to get it as best I can right there. And then eventually we're going to shade above because it is greater than. Let's go ahead and graph this other one here. That is y is less than negative 2x minus 3. So down here, minus 3 right there. And then down to over 1. I guess these lines are going to be kind of, I guess in a way, parallel. As far as the shading, we'll have to kind of go and look through. So, yeah, but I kind of like this. Oh, and I screwed that up there. That needs to be dotted lines right there. And if you mess it up, sometimes I'll just go and erase little spots there. Just make sure you emphasize which way. So, all right, let's go back to the red line. So we were greater than. So we'd be above this right here. And then the other one was less than that blue line. So the big thing we were talking about earlier is we were looking for where the shadings overlap. We need the overlap in the shaded regions right here. Since there's no overlap, means that we have no solution here. And I don't know how often you don't see a ton of examples like this, but sometimes you will. So that means no solution. There you go. Okay, so make sure you write that. So that's kind of a weird one. That might be a good one to put a star next to right there. Yes, there's a little bit of shading, but there's no overlap between. So, okay, let's see what's going on with this one here. We got this equation's ready to go. Both of those actually are ready to go. So let's do the x is greater than negative 1. So that would be a vertical line through negative 1, since it doesn't have a y. And we'll shade to the right of that here in a moment. Let's do this other one here that's already got y by itself. So let's do that in, I guess, red. So it's starting at 2, and it's got a slope of up to and over 3. So notice these aren't going to intersect at perfect points. That's fine. We don't really care if they do. And then this last one, I guess we're going to do in purple here. So we need to divide by 3 first. So that'd be y is greater than 4/3 x. So I'll start there at 0 and then up 4. 2, 3, 4, and then over 3. And then I guess I'm going to go down 4 and then left 3 right there. And that is also a dotted line. we go. And it looks like it's probably going to be shaded in between all the different lines, I guess, here, but we're going to double check. So the first line, the blue line, we were to the right. Okay, greater than, right? So greater than is to the right only on the vertical lines, but never think of left and right with the other ones where it's like in terms of y, I guess. This one right here, y is less than the red line, so everything below our red line. Okay, and then this last one here, y is greater than this purple line. So you're trying to, once again, figure out where all three of them at the same time are overlapping. And that is in this region right here, this, like, I guess, triangular region. That is all of the different solutions that you could have right there. So that's graphing inequalities. Those are not too bad there. Sometimes they might ask you to write some inequalities here for this one. So look at this red one right here. So I'll color code it. We got a horizontal line, so it's going to be like a y equals 3, except it's not equal to because you're shading above, so we're going to do greater than or equal to 3. Now, as far as the blue line goes, we need to figure out the y-intercept. It looks like it's at 1, and then it looks like the slope is going up 2 and over 1, so I think we're going to go here, y with 2x and then plus 1. And then since you're shading above that blue line as well, that's going to be greater than or equal to. Or actually, I'm sorry, just greater than. It's regular greater than because it's a dotted line. And that would be your system of inequalities. Basically, the same thing we had been doing, except we're going backwards, starting with the graph and then, ending with the equations or inequalities. Next little section here, I guess these are kind of separate. Yeah, these are separate.